Okay, the next question we want to figure out is how can I determine the end behavior, a polynomial, from its function? So let's say we're given a function right here, f of x is equal to 2x to the fifth plus 3.5x to the fourth minus 2.5x to the third minus 2.5x squared plus x minus 2. And we want to figure out the end behavior of that function. Well, there's two methods to do this. Method one, which takes a little bit longer, is graphing in your graphing calculator to determine the end behavior. Let's do that method first. So what we have to do is get our graphing calculator out, and first thing you need to do is go to the y equals, just like I have here, and we got to put in the function, and I've already done that. And after you put in the function, click on graph, and it will graph that function. Now this window might be a little bit different for you, but you can change the window accordingly. And we got our function here, and so we got to figure out the end behavior. Now the end behavior is, again, what is happening to this function as it goes to negative infinity, and what's happening to this function as it goes to positive infinity. Well, as it goes to negative infinity, what's happening to this function? Well, it looks like it's going down. So as it goes to negative infinity, this is falling or decreasing. And what's happening as it goes to positive infinity? Well, as it goes to positive infinity, this thing looks like it's going up, so it's increasing. Okay, so that's using a graphing calculator to figure out the end behaviors of a polynomial function. Now, how can we use or determine that without a graph? Well, it's actually not as hard as you might think. The step method 2 is just to look at the term with the large degree. That's all you have to do. And you got to memorize a few things, but if you don't memorize it and you put in these notes, you should be good for most situations if you memorize it. So we got to look at the term with the largest degree. Let's take a look at that term. Let's find it here. Let's term with the largest degree. Oh, it's this 2x to the fifth. That has the largest degree up there. 5 is the largest degree. So let's just kind of write that down. 2x to the fifth down here. Okay? And so what we have to do is look at two parts of this. We first have to look at the coefficient of it, and we have to look at the degree. So if we look at the coefficient, all we need to determine is this coefficient positive or negative? Is it positive? Well, it turns out this one is positive. So we would look down this row right here. And because it's positive, we're dealing with this section here. We got the positive leading coefficient. So we need to focus in on this row right here. Okay? Then we need to look at the degree of this leading coefficient or leading term. Well, the degree of this one is 5, so that makes it odd. And so this is what the end behavior is for this scenario. And I'll just put this here as an example. We had 2x to the fifth. As this function, just like we found before, goes to negative infinity, it's dropping. If it goes to positive infinity, it's increasing. Here we got another situation, and our example is y equals x squared. Well, the coefficient of this is positive, right? It's a positive coefficient in front. And the term, or the degree of this, is even. Right there. So what would happen to this one? As it goes to negative infinity, it increases, and it goes to positive infinity, it also increases. There might be something weird going on in the middle. Maybe it looks like this or something like that, but it always ends up like that. And this other one, just to draw something. Something's going on in the middle, who knows, but then it always ends up like that. Okay, let's take a look at this bottom one. Here we got an example of y equals negative x squared. Well, our coefficient is negative, and our exponent again is even. And so in this situation, you're going to have some graph that looks like this, where it's, like that, something weird is going on in the middle, and it comes back down. And moving over here, examples, we got y equals negative x, or y equals negative x to the third. Again, we have a negative coefficient, and we have an odd exponent, and in this situation, you're going to have it increasing to negative infinity, but in the middle, weird stuff's going to be happening, and then it decreases down like that. And so if you just take a look at the leading coefficient of a polynomial, that can tell you the end behaviors of this function.